Today I want to talk about a topic that's relevant to all of us as a programmers, and that is how to improve code quality using flowcharts. And as you know, one of the most important skills we need as a programmers is the ability to communicate our ideas and solutions effectively. And whether we are working with other professionals or collaborating with fellow programmers, it's crucial that we are able to convey the logic behind our code clearly and efficiently. And that's where flowcharts come in. Flowcharts are a graphical way to represent the logic or a process of a program. And by using symbols and arrows to illustrate the steps and decisions in a program, flowcharts can make it easier to understand and analyze the code. They can be used to create a high-level overview of a program's logic, or they can be used to illustrate specific algorithms or functions. And in this video, we will be exploring the role of flowcharts in programming, examining their pros and cons, and discussing their effectiveness as a communication tool. We will also be investigating how flowcharts can improve code quality and efficiency. And by the end of this video, I hope you will have a clear understanding of the value of flowcharts in programming. So let's get started. To better understand the role of flowcharts in programming, think of them as blueprints when building a house. Just as blueprints are used in construction to map out the design and layout of a building, flowcharts are used in programming to map out the logic and process of a program. A blueprint for a house provides a visual representation of the building's design, showing the placement of rooms, windows, doors, and other important features. And similarly, a flowchart provides a visual representation of a program's logic, showing the sequence of steps and decisions involved in achieving a specific outcome. And when building a house, a blueprint is essential to ensure that the construction process proceeds smoothly and that the final result meets the design specifications. And similarly, a flowchart is essential in programming to ensure that the code is well structured, logical, and efficient. But keep in mind, just as a builder may encounter unexpected challenges during construction that require adjustments to the blueprint, a programmer may encounter unforeseen issues during the coding process that require adjustments to the flowchart. So when you are making a flowchart, it can be changed during the coding process. And overall, both blueprints and flowcharts provide a visual representation of a complex processes that help ensure accuracy, efficiency, and effective communication among team members. Using flowcharts can provide several benefits to programmers, such as flowcharts can help identify potential logic errors, missing steps, or incomplete processes in a program. By creating a visual representation of a program's logic, it becomes easier to spot potential problems. Flowcharts can help break down complex programs into more manageable components. By illustrating the program's logic, programmers can more easily understand how the program works and identify areas that can be simplified or optimized. Flowcharts can be used to facilitate communication between programmers, project managers, and other stakeholders. By providing a clear and visual representation of a program's logic, flowcharts can help everyone involved understand how the program works and identify potential issues and areas for improvement. Flowcharts can also be useful for maintaining and updating programs over time. By having a visual representation of the program's logic, programmers can more easily modify or update the program without introducing new errors or issues. While flowcharts are a useful tool for improving code quality, there are some disadvantages to consider. One potential issue is that flowcharts can become overly complex or difficult to read, especially for larger programs. Additionally, flowcharts can be time-consuming to create and may not always accurately reflect the actual code. Flowcharts can be extremely effective in game development as a communication tool. Game development involves multiple team members with various specialties, including programmers, artists, and designers. With so many moving parts, it can be challenging to ensure everyone is on the same page and working towards the same goal. Flowcharts can help by providing a clear and visual representation of the game's logic and processes. This can be useful in communicating ideas and concepts to team members who may not be familiar with the technical aspects of programming. For example, a game designer may create a flowchart outlining the game's user interface and the interactions between different elements. This flowchart can then be used to communicate with the programming team, who can use it as a blueprint for coding the interface. Flowcharts can also aid in identifying potential issues or areas for improvement in game's logic. For example, a flowchart outlining the game's combat system may reveal an imbalance in the difficulty curve or a potential bug that could be exploited by players. By identifying these issues early on, the team can work to address them before they become major problems for players. Overall, flowcharts can help ensure effective communication and collaboration between team members, leading to more efficient and effective game development. One of the main benefits of using flowcharts is that they help to develop computational thinking skills. Computational thinking is a problem-solving process that involves four key elements: decomposition, pattern recognition, abstraction, and algorithms. Decomposition is the process of breaking down a task into smaller parts. When creating a flowchart to illustrate the steps in a program, you can separate every action and trigger into shapes. This allows you to divide the input, output, and logical decisions into individual elements. These elements are then connected using lines with arrows to show the flow of information. Pattern recognition is the ability to look for similarities. When mapping the parts of a program, you can use flowcharts to notice the instructions that repeat. Within the flowchart, you can then create a series of steps with a line that joins the last step to the first step. This illustrates a loop within the code. Abstraction is the ability to focus on important information while ignoring irrelevant details. Designing a flowchart encourages you to be concise. This form of graphic organizer has limited space within a shape to describe each step. Moreover, there is often a restriction based upon screen or document size. These limitations require that you focus on relevant details only. Algorithms are step-by-step instructions that outline the solution to a problem. In the case of a flowchart, the algorithm is transformed into a visual organizer that maps the steps in a program. Flowcharts are a powerful way to represent algorithms as they provide a clear visual representation of the sequence of steps that require to solve a problem. In addition to developing computational thinking skills, flowcharts also encourage modular design. Modularity is the process of breaking a program down into smaller, more manageable pieces. By breaking a program down into modules, each module can be tested and debugged individually, reducing the likelihood of errors in the final program. And by promoting modular design, flowcharts can also improve the overall readability and maintainability of code. Modular code is easier to read and understand, and changes or updates can be made to specific modules without affecting the entire program. This makes it easier to maintain and update programs over time, resulting in higher quality code overall. By developing computational thinking skills and encouraging modular design, flowcharts can help programmers to create cleaner, more efficient, and easier to maintain code.